I'm assuming A is true. That's given. But I think if A is true, I don't know, you guys help me with those rules of inference. I know I had them on the board really quick with my book. But if A is true,
N is false.
do I know N is false?
It doesn't matter if N is false or true, does it?
Well, that's what's going to ask you next. What can you say about this?
It's true.
Yeah, I
The
think
whole
it's true.
statement is true.
And so, is that N over there?
Yeah.
So I get A and it's true because of statement number 5, as well as that one rule of inference we called. What's that? I'm being honest, I don't remember what it's called. Does anybody?
Disjunctive syllogism.
No, disjunctive syllogism was different. That means it was if P and Q are true. If P or Q is true, and one of them is false, I know the other one's going to be true. I think this is an example.
Modus ponens, maybe? I'm just guessing.
No, it's my addition on the very bottom. So it's an example of the addition rule of assignment. And I maintain if A or N is true, well, look at the rest of the argument.
Then M or E. M.
So if the premise is true by modus ponens, certainly it's going to be the case that M or E is true. Well, you guys, do you see where I'm going with this? I want the very last line to be my conclusion, which is W.
Mm-hmm.
And again, unlike truth tables, I'm assuming these individual statements are true statements. So I'm not really digesting, or I should say dissecting into true or false values. However, if I now have M or E is going to be true, then what can you say about this particular statement? Not the whole thing, just what's left in my hand.
True.
Why?
Because we know MB is true.
Well, it's the addition again, isn't it? Because I know this is true, then certainly M or E. Or the I forgot the letter. R is going to be true as well, by the addition, rule of inference. However, if this premise for this conditional statement is true, then necessarily the conclusion of that conditional statement is going to be true as well. That means D or W is true. And do you guys think we can stop for a minute and just play a little chess?
Okay.
I'm trying to get to this true.
Mm-hmm.
How can I get that to be true from this? Yeah, if I can show D is false, then by disjunctive syllogism, one on my list here, I will be able to show this is true.
Yeah.
In order to show that D is false, oh look at that, I just have to show that E is true. Now to show E is true, how can I get that?
Because you stated
Very
it
nice.
before.
So do you guys think, since D or W is true, it's now known to be true, doesn't that necessarily imply N is false? Or shall I say, not N is true? But if you connect this to my third statement, which I know to be true, yet I know M is false, doesn't it necessarily imply
That E is something that is true.
E is true as well? Right? Again, disjunctive syllogism. However, if E is true, did I misspeak? So E is true. If E is true, what's next?
Not B.
Why not E? I'm a little confused there.
Just statement.
No.
So if you come down to this conditional statement, I mean, if we do know that E is true, then we do know that D is going to be false. Or shall I say the negation of E is true? So I maintain the fifth statement of this argument, I've actually forgot the letter, guys, that not D is true. But if D is not true, then take a peek at what happens when you come in here. I mean, I actually already assumed, or I shouldn't say assumed, I've already shown that this has to be true. But if D is false, what can you say about W?
If W is the only thing that is true.
Yeah, again, by disjunctive syllogism, it certainly is the case that W is going to be true. So, statement number 9. Therefore, W is true. It's just a more sophisticated way of determining the validity of an argument without necessarily going through the truth tables. So I was just talking about a proof structure more elevated, more even elegant than just crunching out those truth tables. So, Anthony, you mentioned something about deductive logic. Now, I gotta confess, you guys, I am using deductive logic here. Deductive logic is very different than inductive reasoning. Deductive reasoning is more like taking a generalization and bringing it down to a conclusion that's more restricted. Inductive reasoning goes in the opposite direction. It takes particular instances and blows them up into general statements. Another difference is that inductive reasoning relies on observation, but deductive reasoning is all a priori, it's internal. That's Latin for reducing the argument without actually observing anything. So, I maintain that as scientists and mathematicians, for the most part, we don't abide by inductive reasoning. Here's an example of inductive reasoning. Every day in my life I've risen and the sun has risen. The sun, excuse me, that's poor English, isn't it? And the sun has risen. Doesn't mean necessarily tomorrow when I wake up the sun will rise, does it?
Not
That's
by
inductive
that
reasoning.
reasoning.
Yeah,
but
that's
the
inductive
sun will
reasoning.
rise tomorrow.
What if, and besides it, relies on my observation. What if I told you this is a true statement, that every car is painted red? And I told you I have a car. What can you conclude about my car?
That's right.
It's
It's gotta be
red.
red. You don't have to go to the parking lot and see my car. You can deduce that the car is red. It went from a generalization of all cars are red down to, well, my particular car is red. That's an example of deductive reasoning. And this is an example of deductive reasoning. I admit mathematicians do assume a certain type of inductive reasoning called inductive mathematics, or excuse me, mathematical induction. And probably all of us, maybe one of us has not seen mathematical induction as a proof technique, right? Was that right?
Yes.
Okay. You're scaring me.
That was fun and pre-calc.
That's right. We just did the summer pre-calc. Well, you guys, I still don't think I'm being sophisticated enough.
I was wondering if we get to see mathematical induction later on in calculus courses. I hope so.
What class are you taking right now, Anthony?
Math 30?
Do you know this yet? Do you know this is true yet?
Yeah, the derivative. The power rule, yeah. I know that. Chain rule.
Shoot, never mind. I'm sorry. Mathematical induction is not used in verifying that. I'm thinking of definite intervals.
Oh yeah, I remember doing that in AP Calc.
Did you ever come across this statement?
Yes, I know where you're going with this. The summation of,
The first squared integers.
yeah, taking the limit of the summation and seeing if it's the same as the integral.
So when you saw it for the first time, did your high school teacher just slam it on the board?
Yeah.
Or did he or she prove it?
Slammed it on the board.
Really?
Yeah.
Where'd you take calculus?
I didn't take calc yet. In pre-calculus, they just slammed it on the board. But
Yeah.
Yeah, understand. That's what most teachers do, is they just slam it on the board.
But yeah.
You're one of the few that actually proves
You're the
it.
only teacher
I'm
that
serious.
has proved everything that you put up on the board.
What's that?
You're the only professor I've ever had that's proved everything they put up on
You
the
got
board.
to be kidding.
No, that's true.
Most professors don't. Yeah.
Well, you guys understand that that's what mathematics is, isn't it?
Yeah, I know.
Mathematics is
We
doing why,
haven't
not
really
just how
been
to do
doing
it.
mathematics.
What's that?
We haven't really been doing mathematics then.
But I think it's fundamentally important you see why these statements are true. To prove that one, I would use mathematical induction.
Right.
I shouldn't say that.
Well,
I know I used this example on you, Anthony, this summer. It's exactly that example. You guys, I still think I'm being limited. I know I haven't gotten to the calculus. I feel like I'm rushing because I have so much I have to say to get there. Let me raise this one more level up so that I can use these symbols, which we do use quite often in mathematics. If ever you see this symbol right here, which looks like an uppercase A upside down, I refer to it as my universal quantifier, and it simply represents the phrase for all, or for every. If ever I use this uppercase E backwards, I refer to that as my existential quantifier, and it just simply stands for the phrase, there exists. Sometimes they say, for some. If ever you see this symbol, because I would probably use it, it just stands for the phrase, such that. If I use this e, lowercase e, it just stands for the phrase, is an element of. Oh, I forgot one. If ever I use an uppercase E backwards with an exclamation point after it, it stands for the phrase, there exists a unique, and then something will follow. Yeah, that's right. So, with my definitions, what does that collection of mathematical symbols really represent? As a sentence.
For all values of x, there exists a y,
Such that.
such that.
Such that.
You're missing again.
Where's your such that? Where's your
Oh,
such
I don't
that?
need it. If I put something immediately after these existential universal quantifiers, it stands for such that.
Okay.
I usually use that such that symbol when I combine English words.
So, all right, such that x loves y.
Wow, you said it so coldly like a mathematician. Now there's somebody outside the room who doesn't understand any of this. No, I'm serious. How do you translate this? Again, I'm serious.
We'll just write out the sentence for all x.
No, people outside of this math classroom door aren't mathy enough. They wouldn't understand what you really mean by all this. For all or for every.
All X's have a Y that loves them.
And they outside the door are so math phobic they don't like X's and Y's.
All people love other people. Or if you say that it's like an X and a Y chromosome, so that it's all men love women or something like that.
All people love
Yes, love.
All people love.
Love who?
Dogs.
Love who?
Accent.
Love.
A.
Some.
Someone. That's it. That's perfect. So I think you could translate this reading this.
Everyone loves someone.
Beautiful.
What if you don't love anybody?
I'm just saying it is true. Actually, not even as true or false. I'm just saying how would you translate the math?
That's good. Is that hard for us to say?
There's someone for everyone. For everyone.
Close, close.
Oh,
There's someone.
There's someone loved by all.
No, you have the reverse direction. It goes in the forward direction. There's someone who
Loves all.
loves everybody. There's someone loves everybody.
It's all about love. Go on.
Yes, it's all about love.
Love. There's someone.
There's someone who
Who loves?
loves.
Who loves someone else.
Why?
Oh, my apologies. You guys, I made a mistake. That's not what I meant. Can I take that back? My apologies. That's why you're stalling there.
There's someone who loves himself.
Thank you. But you guys see I can use these in combination, these quantifiers. And I get more elaborate statements or propositions. So what about this? The x-axis, the y-axis. Let's get down to the mathematics. Here's a graph of y equals f of x. And everybody, in my picture, I'm trying to suggest that this is a value of x, I'll call it a. Here's a corresponding value for y in the curve, if it did exist, I'll call it L. Now, I think according to the way I'm drawing this curve, this particular function is not defined at x equals a because there's a hole in the graph. You have to confess that if I took a walk on the x-axis, and I walk towards a from the left-hand side, as I get closer and closer and closer to a, the corresponding y values of the curve seem to be getting closer and closer to L. And by the way, when I take these walks, I never walk in such a way that I plant my feet at x equals a. I don't care what happens when x is exactly equal to a. But if I took a walk on the x-axis and walked towards a from the right-hand side, there too I think as I get closer and closer to a, the corresponding y values in the curve get closer and closer to L.
Your limit.
I might even say, intuitively speaking with mathematical symbols, that the limit of f of x as x approaches a is equal to L. This is our understood, I misspoke, sorry. This is our intuitive notion of what limits are all about. I just don't like it because it's intuitive. I want to be more rigorous. So can I make my formal definition of what this particular statement actually means?
Sure.
So, man-made definition, this is not a proof. This particular statement right here, the limit of f of x as x approaches a is equal to L, simply means the following. In my picture, if you guys don't mind playing for a minute, did I use my red pen? Oh, thank you. In my picture, I think this intuitive notion really amounts to the following. No matter how far I deviate from L, even minutely deviating from L, say by increasing L by, I don't know, how about epsilon units? Or maybe decreasing L by epsilon units. I think if the limit of f of x is equal to L, as x approaches a, it necessarily implies that I can find a deviation from a by no more than delta units. So that if x is chosen between a minus delta and a plus delta, I'll get on the point on the curve which is no more than epsilon units away from L. I think what I just said is true for all values of epsilon, no matter how small they are. Now, I did not make a mistake with my picture, even though I admit I'm sloppy. I know that when it comes to this vertical blue line segment, it doesn't match up with the red one. It doesn't have to. I'm just saying, if the limit of f of x is equal to L as x does this thing, and no matter how small this horizontal band is in red, I can find a vertical band in blue that could give me a y value that is no more than epsilon units away from L. I will now write that in terms of mathematical symbols. This means, for all epsilon greater than 0, there exists a delta greater than 0 such that in absolute values, the deviation from L by my y values in the curve are no more than epsilon units whenever in absolute values x minus a is no more than delta units. Oh shoot, I forgot something. When it comes to limits, we don't care if x is exactly equal to a. Is everybody there? And I maintain, as an alternative form, if you guys don't want me saying this, what you see right here between my fingertips could be rephrased. That is this. As a statement, necessarily implies this. Means the same thing. So do you guys think I can now give you an example of a proof that a limit exists, and it is what it is, using my formal definition? And my first example is going to be too simplistic. We're going to have to make it more sophisticated with my second example. But just get a feel for this. By the way, if there's somebody here who's not in math theory already, and you haven't seen this, but in math theory, you will see it. I hope you better. I'm really nervous. I haven't done a class this semester. Most of my students say they never even saw it, or at least never got any practice with it.
Yeah,
A lot of students tell me that they haven't seen
How
this.
many of you have written proofs using this definition?
Have what, written proofs or solved them? What do you mean?
Well, formally written a proof.
Written?
Use
Written
it.
definition. Yeah.
No, not yet.
Now I have.
Yeah, Chuck had us do it. So.
How about a better question? How many of you study calculus here at Sierra and have not used this definition of proof? Oh, really?
I don't remember.
Okay, all right. Huh.
Why is this definition so important?
Calculus is based on the idea of limits, and this is the formal definition of limits.
Yeah, I was gonna say, because you don't want your Math 32 professor to get really mad. Now that I'm over my anger,
Sorry.
you guys have to confess, for those who take calculus, the fundamental C, the fundamental definition in the differential calculus is a derivative definition.
Yeah.
But that's the limit of the difference quotient. The fundamental C for the entire integral calculus is your formal definition of the definite integral. But sheepers, that's defined in terms of the limit of a Riemann sum. So it's embedded in the foundation of both branches of mathematics. Sorry, both branches of calculus. I gotta confess, beyond Sierra College, for those of you who are gonna study more math, is there anybody here who's gonna study more math beyond Math 33? You'll be studying some subfields of mathematics where that's all this is. Well, actually most of it, a lot of it. Particularly a real analysis is a typical field that uses a lot of this ideas. Topology is another one that could. There's a lot of different ways of studying topology. One way is to look at these balls, or these neighborhoods we call them. So you guys, let me give you a formal example. Prove, I'm just making this up, the limit of 2x minus 3 as x approaches, how about 4, is equal to, I know you and I understand this to be trivial. True, we just plug 5 in for x, and that's what we get, 8 minus 3. But to prove it, I am going to come up or pull out a piece of scratch paper, and we will find, in my definition, a delta that works. So let's just do that on my piece of scratch paper. I know I raised the definition, but it says, given an epsilon greater than 0, there exists a delta greater than 0 such that in absolute values, the f of x deviation from L is no more than epsilon units whenever. In absolute values, x minus a is no more than delta, but again, we just don't care if x is exactly equal to a. Ah, shoot, I'm being too general again, aren't I? Sort of like copying down my definition. Let me substitute in another name for f of x. I said, let me substitute in another name for f of x. I can say that 3 times. 2x minus 3.
Minus 5.
It's less than epsilon.
Whenever this is true. Actually, I forget. Is it a 4?
Yep.
Now, you guys, if I can massage the inequality on the left-hand side, to have the absolute value of x minus 4, then maybe I can somehow relate the delta to my epsilon. And I think I can, removing parentheses since they're superfluous. Combining like terms, because I can. Factor out of 2, algebraically.
Finish your absolute values.
Thank you very much. And I think the absolute value of product is a product of two absolute values.
Yep.
And to isolate the absolute value of x minus 4, I see the absolute value of x minus 4 is less than epsilon over 2 whenever the absolute value of x minus 4 is less than delta. Doesn't that tell me I can choose my delta to be
Epsilon over 2.
halves? So everybody, that's important. And keep in mind that I started this discussion by saying, let's assume I've got an epsilon greater than 0. And how do I find the corresponding delta? I'm sorry if I'm tired. So I don't know if I can come up with a better example of this. I'm being tired. I think some of you have heard this already. But my boss stuck his head in the door. And he's screaming at me. He's saying, get your machine, produce these ball bearings, and you better make ball bearings like I want them. I want to have a volume of 1 cubic millimeter. And he's saying, if you give me some ball bearings at the end of the day that deviate from 1 cubic millimeter by more than 1/10 of a cubic millimeter, you're fired. So I go to my machine and I start sweating bricks. I'm panicking because I look at the machine, I realize when I put the input in, it only calibrates the radius. So I got to figure out what the corresponding radius is for a sphere whose volume is 1 cubic millimeter. And I got to worry about how I deviate from that radius, by how much can I deviate so that in the end the volume doesn't deviate from 1 cubic millimeter by more than 1/10 of the cubic millimeter. The 1 cubic millimeter is,
Epsilon.
I think, my L. And the epsilon is, the epsilon is 1/10 of the cubic millimeter. The A is,
The radius?
yeah, which is,
I get the original statement.
what would the radius of a ball be, of a sphere? Anybody?
It would be your,
Oh, you're closing your eye.
it would be your delta in this case.
What is A? What is A
Yeah.
in this case?
Um,
The square root of 3 over 2 times the square root of pi?
Right.
oh yeah.
Oh, I made a
the
mistake. It's the
equation.
cube root of 3 over the cube root of the quantity, 4 times pi. Yes, no? Okay. All right. Oh, by the way, the delta's going to be,
What?
What's that?
It's going to be.
in my example with my boss screaming at me.
0.05,
What unit
which
is
would
that?
be the epsilon
Oh,
divided by 2.
close. I think the delta's going to be how far I can deviate from the cube root of 3 over 4 pi
It's gonna be, okay, so.
to get a volume with the epsilon units of L. So everybody, does that make sense with my proof?
Well, you haven't proved anything.
Good. Doesn't make any sense in the sense that I haven't proved anything. This is scratch paper. So now I got to formalize my proof.
I was gonna ask for the last line,
Mhm.
you're saying that this basically is a way for you to relate epsilon to delta? I don't see.
No, the other way around. It's a way to relate delta to epsilon because my boss is already coming in screaming, you're giving me the epsilon value. I got to find the corresponding delta that gives me x values within delta units of A.
Okay.
And that's why, again, I start my arguments off by saying, let's just assume I've got an arbitrary epsilon greater than 0. So everybody,
So much.
let me formalize my argument. So part 2. Let's show that this particular choice for delta works.
Do we know what our epsilon is yet? We
No.
know that, we
Matter
know
of
that
fact,
our
I don't-
delta is equal to epsilon over 2, but
True. As a matter of fact, in this argument, I don't ever want to specify epsilon.
Yeah.
Because I want this argument to be true for no matter what epsilon is, I can find the corresponding delta.
okay.
So, everybody,
Forever.
let's let delta be equal to half of epsilon. Given for all epsilon greater than 0, I want to be able to assume that this particular premise is true. And I want to be able to conclude that an absolute value is the difference between my f of x, which is 2x minus 3, and my L, which in this case is positive 5, is going to be
Epsilon.
less than
Less than
epsilon.
Or less than
And
epsilon.
if I can bridge that gap, if I can show you, if I can prove to you that the absolute value difference is less than epsilon, then by my definition, I prove that the limit of 2x minus 3 is indeed equal to 5. See guys, let me put the details in. Let me bridge the gap. I know you're going to yell at me saying you're duplicating your work already. I am duplicating my algebraic work, but I'm formalizing my structure of the argument. I think that's the same as this, which is nothing more than this. And we're math D experts, so we can do that. But the absolute value product, yet again, is a product of two absolute values. Okay, now I'll slow down. Here's the important part. I've already made the assumption that whenever I come across the absolute value of x minus 4, I'm making the assumption that it's strictly less than delta. Oh, I forgot my 2 out front. I'll put it in. But I also made the assumption that when I see delta, I can replace it with epsilon halves because they're equivalent. And with a tad bit of cancellation, I'm left with epsilon. So I have proven that the limit of 2x minus 3 is indeed equal to 5. Let me state it. Therefore, the limit of the quantity 2x minus 3 is indeed equal to 5 as x approaches 4. For those who don't know me, here's my mental hiccup. I didn't have a proof telling you, the reader, that I'd proven what I wanted to show. You guys might be used to this instead. QED stands for
Quote, erat demonstratum.
or erotic demonstratum in a different tense. It's just Latin for that's what we want to demonstrate. I see a lot of high school teachers who do this. W to the fifth, which was what we wanted. So you guys are curious, what do you use at the end of the proof? What does your professor use? QED. Box is a typical one, particularly with textbooks because these are different. Yeah. And by the way, I'm not making that up. It's a fairly standard symbol we use back in this. Oh, something else I might not have mentioned. If you see a diagonal slash left of a collection of triangles, it just means my last therefore in a proof. You guys, how am I doing on time?
Is there
Am I doing?
a time limit?
I don't know if there's a
Well,
time.
the meeting was supposed to end at 2:30, so if you need to go, feel free, but
Can I
kind of barely scratched the surface here, so if
Yeah.
you guys want to keep going,
Can
perfectly
I at
fine.
minimum give you one more example? I don't like this example. It's way too easy.
Could we do a
Quadratic.
30, or could we do maybe a 32 example?
What's that?
Can we do a 3D example?
Sure.
Okay.
Math 32.
Math 32.
Totally down.
3 variables?
3 variables. Jeez. All right, let me think about it.
Okay.
Sorry, I need more room. I hope that didn't strike you the wrong way. You guys, is my arithmetic correct?
Yeah, that's it.
I'm sorry, I'm just really tired. Can anybody validate if my arithmetic's correct?
Yes.
Yes.
Okay, it is. And if I'm going to prove that the limit of the quadratic expression is indeed equal to -7 as x does this thing, well, I'll pull out my nifty piece of scratch paper. Let's see when I find a delta that works. So, given an epsilon greater than 0, we need a delta greater than 0 such that in absolute values, my f of x minus my L is no more than epsilon units whenever in absolute values x minus 2 is less than delta but strictly positive. You guys, it looks like I'm going to have a very similar argument to what I did before. And paying the consequence, algebraically speaking, when I clean this mess up, you guys, life's a piece of cake, isn't it? Isn't it just an x squared minus 3x plus 2? But I think the trinomial factor is nice.
Yeah.
Did you guys agree?
Yes.
I have a question.
Yes.
I noticed that every time I did these, it was always factorable. Is there a reason why that is?
Yes, because a limit does exist and is that number on the other side.
That's
why.
That's why.
Yes.
It's pretty cool. I just felt like there had to be one where it didn't work.
You
but I
don't
guess-
have to use a quadratic formula.
Okay.
And I maintain that the absolute value of a product is a product of two absolute values. You know what, you guys, maybe I made a mistake. Maybe this is more sophisticated than the last one. Because I can just divide both sides by the absolute value of x minus 1, can't I?
No.
No.
What do you mean, no, why not?
You have to choose a constant. You can't just divide it by the absolute value of x minus 1, because then you still have an x value in there, and
Okay, I think you got to the key point. If I divide both sides by the absolute value of x minus 1, I'm trying to find a delta that works in terms of epsilon. So I need some kind of numerical factor of epsilon, even as a fractional one. Secondly, if I divide both sides by this variable expression, I'm in deep trouble. I can't divide by 0, and who knows, maybe x is equal to 1.
So why not try to break this up into different problems, like x minus 1 and less than epsilon? Could you do that?
Oh,
Something like-
unfortunately not, because that
like
wouldn't
that.
give me the control between them each. But what if I did this? What if, let me take a break. I'll pull out a piece of scratch paper.
Like with absolute values, you have x minus 1 is greater than epsilon, and x minus 1 is less than epsilon. Except that doesn't quite work for the multiplication now.
Yeah, that multiplication is really going to mess that up.
I know.
So I got an idea. Check this out. If we can find a constant, say c, such that in absolute values x minus 1 is bounded above by c, then wouldn't we over there to the left-hand side be able to conclude that the absolute value of x minus 2 is less than c over, excuse me, I misspoke, is less than epsilon over c? Now, I think that would be slick if we can find such a constant c. Just go and find one. If delta is equal to 1, do you guys mind if I make up a delta value of thin air?
Sure, no,
So if I can make up a delta value out of thin air, if you can read that, delta equals 1, then I think what's going on is that with my premise, the absolute value of x minus 2 is less than the delta value. That was my assumption. Oh shoot, you guys, you know what? In mathematics, it's really difficult to deal with absolute value bars, so can I get rid of them real quick? Getting rid of them. I think to say that the absolute value of x minus 2 is less than 1 really means this. What's hiding underneath my hand is a number on the real number line whose distance from the origin is no more than 1 unit. So using my math D skills, I think this simply means that x minus 2 as a number on the real number line is sandwiched between 1 and negative 1. I'm merely translating my inequality involving absolute value bars into a double inequality not involving them. Now, if I want an upper bound for the absolute value of x minus 1, then I'll do what I typically do in mathematics. If I want something, I just create it out of thin air. I'll call the middle x minus 1. It's not legal. What I'm really doing is I'm adding 1 to the middle section of my double inequality. To make it legal, I'll add 1 to the other sections as well.
Why didn't you add 2 to all of it?
Yeah.
Because I want to generate a constancy that's an upper bound for the absolute value of x minus 1. That's my goal. So that's why I forced this expression inside the absolute value bars to be in the middle section of my double inequality.
Okay, so that constant has to be between 0 and 2, it looks like.
All right, that was a good way to put it. The number hiding underneath my hand is on the number line between specifically the numbers 0 and 2. I'll say it differently. That means its distance from the origin is no more than how many units?
0.
But if I live between
Well, it's no more than
1 and
2.
2 on the number line, I'm anywhere in there. What's the greatest distance I could be away from the origin?
2.
2 units. Aw, shoot, that means my c is equal to 2. And since c is equal to 2, then I suppose my delta is going to be epsilon over c. And my c in this case was 2. Shoot, you guys, I blew it. You got to look at those two particular statements that I have in blue. Because I now have that delta is going to hold one of 2 values. I'm unhappy.
Thank you. Yeah, I have to do those things.
You got it. And to fix it, here's what I'll do. Finally, let's choose delta to be the smallest of these 2 values. The smallest between that number 1 and the epsilon over 2. Shoot, you guys, I got